Alright, so today we're going to talk about two-dimensional motion. The objective for this PowerPoint is that students will be able to recite equations and facts related to two-dimensional motion. You'll need something to write with and something to write on. And don't forget to take the Edmodo quiz after completing these notes. So, we've already talked about objects moving with constant acceleration and constant velocity. We've talked about things moving horizontally and vertically. But we haven't talked about things moving side to side and up and down simultaneously. This is called two-dimensional motion, because it's moving horizontal and vertical simultaneously. So we can break up any two-dimensional motion into its constituents, its vertical part and its horizontal part. So for the symbols we're going to use in the equations, think of a y-axis and x-axis. So the distances as y's are going to be verticals or heights, and any distances labeled as x's are going to be horizontal distances. The vertical component is free fall acceleration, the stuff we just got done talking about, with all that g and y stuff. Well, for an example, this part here says the vertical component of two-dimensional motion is free fall acceleration. This does not depend on how fast it's moving horizontally. That means a ball launched horizontally, the yellow one in the picture, and a ball dropped from rest, the red ball, will hit the ground at the same time if they're released from the same height. So each one of these lines there in the picture is like a different unit of time, so to speak. And the yellow and red ball would hit the ground at the same time, even though one's going to the right and the other one's going straight down. Alright, so that vertical part, we're going to use the equations we just got done talking about, where a becomes g, and x and x naught become y and y naught for heights instead of horizontal distances. And the value of g on any problem pertaining to Earth is negative 9.81 meters per squared second, the strength of Earth's gravitational field. For the horizontal part, we don't need to worry about anything vertical, so we'll just use the average velocity equation. Gravitational field has no effect on how it moves horizontally, just like the yellow ball in that picture on the previous slide. So that's just displacement over time. When we launch things at angles, we also need to be able to separate the initial velocity into its components. So I'm going to do a picture here as an example. So if we were to shoot something from a cannon with an initial speed of 25 meters per second, that's at some kind of angle to the ground. So we can't just use that in an equation, because there's actually two parts that make that speed up. We draw a triangle on this, then it becomes obvious we have to do some trig. Let's say that's 30 angles there, or 30 degrees there. This horizontal part, or the adjacent side to where theta is, so to speak, we can define that as the initial velocity, the 25 meters per second, times cosine of whatever that angle is, in this case 30. This is what I'll call the horizontal component of the initial velocity. The vertical part on the right side, or the opposite side of the triangle, according to trig, would instead use v sine theta. So for the horizontal parts, think cosine, for the vertical parts, think sine, and either way you're multiplying those trig functions times the initial velocity straight out the cannon. Then we can use these as the initial velocity in the previously mentioned equations that we already know. More on this in class, because that probably looks confusing. So to recap this lesson, we're going to use the acceleration equations to describe the vertical part of two-dimensional motion, and we'll use the average velocity equation to describe the horizontal part of two-dimensional motion. Any projectiles launched at angles can have their initial velocities broken into horizontal and vertical components using some trigonometry. So that's it for this lesson. Make sure you go onto Edmodo and take the Edmodo quiz to receive homework credit for this note-taking experience. Thank you.